We spend a lot of energy worrying that AI lies about its reasoning. This paper asks a refreshingly different question. Forget catching lies for a second. When a model explains itself, does that explanation actually help you predict what it will do next? And the answer, encouragingly, is yes. Here's the problem with how we usually test faithfulness. Most methods try to catch a model using a hidden bias or making a logical slip. But frontier models are getting too good to fall for those tricks, so the signal vanishes. Even Anthropic's own model card admits they have no solid evaluation for reasoning faithfulness. So the authors propose a simple, durable principle. A faithful explanation should help you predict how the model behaves on similar inputs. Picture two patients, identical except for age. The model says one has heart disease and the other doesn't. If age is what flipped it, a faithful explanation had better mention age. They turn that principle into a concrete test. First, a reference model answers a question and explains itself. Then a second model, the predictor, tries to guess how the reference model will answer a slightly changed version. It guesses twice, once without the explanation and once with it. If the explanation is faithful, seeing it should make the predictor more accurate. Here's the whole loop in one picture. The gain in the predictor's accuracy, from adding the explanation, is exactly the signal they care about. They package this into a metric called Normalized Simulatability Gain, or NSG. It's the fraction of the possible improvement that the explanation actually delivers. An NSG of 1 means the explanation lets you predict perfectly. 0 means it's useless. And a negative value means the explanation is actively misleading. One clever detail makes this work. Prior methods build counterfactuals by randomly inserting words, which drifts into nonsense. Instead, these authors pull counterfactuals straight from real datasets, changing at most 2 features. The variations stay realistic, so the test is fair. The scale is serious. 7 datasets spanning health, business, and ethics. 7,000 question pairs. 18 frontier models, from QN and Gemma to GPT-5, Claude, and Gemini. And an ensemble of 5 predictor models, so the result doesn't hinge on any single judge. And here is the headline. Every single one of the 18 models produced explanations that made the predictor more accurate. The dark bars are guessing without the explanation, the hashed bars are with it. The explanation always adds a lift. In numbers, the normalized gain ranges from 11 to 37% across models. For the best ones, the explanation fixes roughly a third of the predictions you would otherwise get wrong. That's the positive case. Self-explanations really do carry useful information. Does this improve with model size? The answer is a messy maybe. Within the QN family, it climbs steadily with scale, and Gemma trends up too. But among the big proprietary models, there's no clean pattern. Weak models are weakly faithful, then the effect plateaus past a modest capability threshold. Now the most intriguing result. Maybe any plausible explanation helps, regardless of who wrote it. To test that, they replaced each model's own explanation with one from a different, sometimes stronger model that gave the same answer. The model's own explanation still won. Models seem to have privileged access to their own reasoning. The self-explanation advantage held across every family, from about 1 to 4 extra points of NSG. And here's the kicker. Even Gemma, which does no explicit reasoning, showed the boost. That points to a genuine introspection effect, not just a peek at a reasoning trace. But let's be honest about the failures. Authors define egregious unfaithfulness as an explanation that leads every predictor astray. Around 5 to 15% of explanations are this bad, with the small open models worst, near 15%, and frontier models around 7%. Here's a chilling example from GPT 5.2 on a self-driving trolley problem. It refuses to swerve, invoking a principle of not taking active measures. Flip the genders of the people involved, and it suddenly does swerve. Claude Opus 4.5 makes the same about-face. The stated principle was not the real reason. What kind of features trip up the explanations? Reassuringly, not the sensitive ones. In the income task, education level and occupation drove most of the unfaithfulness, while race, sex, and age were neutral. The models struggle to articulate technical reasoning, not to hide social bias. And unfaithfulness isn't the same as importance. In the breast cancer task, radiation therapy drove the most unfaithfulness, yet the single most decisive feature, the tumor's malignancy grade, was explained perfectly faithfully. Faithfulness also depends on the topic. It was highest on diabetes prediction, at nearly 43%, and lowest on the moral dilemmas, around 6%. Models are least faithful, exactly where we might worry most, on ethics. A surprising appendix nugget. The model's short, user-facing explanation was actually more predictive than its full chain of thought, which was over 5 times longer. Sometimes the tidy summary tells you more than the rambling scratchbed. Why does this matter? A lot of AI safety leans on reading a model's externalized reasoning. This work gives developers the first faithfulness test that won't go stale as models get smarter. Self-explanations are imperfect, but they clearly carry real signal, so we shouldn't throw them out. The one-line takeaway. An AI's explanation of itself is far from perfect, but it genuinely helps you predict what the model will do, and it even reveals things an outsider could not guess. If you enjoyed this, there is a new paper decoded every week, and you can suggest one in the description.